All right, so today you're going to be working on lesson 11 called On or Off the Line. Lesson 11 is kind of pivotal part of Unit 4 because we're now switching from just solving equations to what we call systems of equations. So today might seem like you're kind of going in a totally different direction than we have been going, and that's okay. We still have the last half of the chapter to cover with systems of equations. So we're going to work on the warm-up counting coins. It says I have $2 in my pocket, and if I only have nickels and dimes, how many nickels and dimes do I have? Go ahead and pause this video and then come up with the combination of nickels and dimes that you think would make $2. All right, so you should have paused. You're coming back. We would obviously share this out, so I'm going to share my answer. I know that a nickel is 5 cents, and I know that a dime is 10 cents. I know my combination is $2. So when you start to think about this, you could start with dimes and you're counting by 10. So I could say 5 dimes equals 50 cents. So that gives me $1.50 to put into the nickels. Or I could say 10 dimes gives me 10 cents. There I have half my money taken by dimes. So then I'm going to use the other dollar for my nickels. So a lot of different combinations are going to work here for nickels and dimes. So I'll just show the one that I thought of. So I know that I have 10 cents, and I thought of using the number 15 for that. So I'm going to multiply 10 cents times 15. I know that that's $1.50 of the $2 that I want to make in nickels and dimes. So I have 50 cents left over. And when I divide 50 cents by 5 cents, I know I could count by fives, 5, 10, 15, 20. I can take 5 cents and multiply it by 10. And that gives me the other 50 cents I need for the $2. So there's my other 50 cents. When I add those together, I get $2 total. So right here I have 15 of the dimes and I have 10 of the nickels. There should definitely be a lot of different combinations here because you don't know how many coins that you could use total. There's no limit on the amount of nickels and dimes. So at one point I could say I use 1 dime and all the rest nickels, or maybe I use 1 nickel and all the rest dimes, and that wouldn't work because nickels are 5 cents. And if I want to get to a complete total of $2, I would need to have to use at least 2 nickels first, and then I could use all my dimes to not leave me with an odd amount left over. So you're going to go to activity 1. In activity 1, we're still talking about change. So Jada tells Noah that she has $2 worth of nickels and dimes. So we're still continuing with this in her pocket, but now she has a limit. She has 31 coins altogether. So she asks him to guess how many type of each coin she has. So you're going to use this table below to find the combinations of nickels and dimes that have a total value of $2. Use the number of nickels given to determine the number of dimes. So you're going to start in the first 5 rows with this pattern of 0 nickels, 2 nickels, 4 nickels, 6 nickels, and you're going to figure out the dimes. You're then going to continue that pattern, keeping in mind that they have to total $2 and you have to have 31 coins altogether. So in the first one, go ahead and pause this and then fill this out. You can work with the person, anybody at your table group that you're sitting at, and figure out the number of nickels, dimes, and total coins in activity 1. Pause this and then come back. All right, so now you've gone through and you have to think about, okay, I've got to get 31 total. And this table might not get you there in every single line, but I know I have to have $2 as well. So if I start thinking about the $2 starting from the warm-up, if I had 0 nickels and I counted by tens, I would have to have 20 dimes to get to $2. And while that equals the $2 limit, that only gives you a total number of coins of 20. So we've kind of met one rule and we haven't met the other rule. So if I change that and I go up by 2 nickels, like I said, nickels are 5 cents. So I have to have a grouping of 10 if I'm working with an even amount of $2. I would then need 19 dimes to go with those 2 nickels, and that now gives me a set of 21 coins total. So I'm still meeting that $2 minimum, but I'm not meeting the number of coins that I want to have in this problem. So I go ahead and I up my amount of nickels to 4. Those 4 nickels then produce an amount of 18 dimes that you need to get the $2. So now we're at 22 coins, and you should start seeing a pattern within the table of, okay, well, when I'm increasing the number of nickels, I have to decrease the dime, but you can see that each time the number of coins is going up a little. So I am increasing and getting to meet that 31 coin goal while still meeting the $2 rule. So if I up that to the number of nickels is 6, I then can see that I need 17 dimes, and now I'm at a total of 23 coins. So I'm obviously doing this very slowly. So they leave you 2 blanks in the nickels. So you should be realizing here, like, okay, when I add 2 of these, I'm actually subtracting these, but I'm increasing my amount of coins. And that pattern continues down this table, right? So if I did that, I could try it one more time, but I know that I'm only going to go from 23 coins to 24 if I continue that pattern. So you might have had to keep going in this table, but like, let's say if I increase this to 10 nickels, well, that's double of what I've been doing. So now I've gone up 4. So if I've gone and doubled that, I'm obviously going to double the amount of dimes that I take away. So now I'm at 15 because I had to take away 2, still meeting my $2 minimum, but now I've definitely bumped up those total number of coins to 25. So I'm getting closer to that 31 coin minimum. So then let's say, like, all right, this is going really slow in my pattern. I know I need to jump up 6 more total coins. So let's say I'm like, all right, well, I'm going to go ahead. I know I need to keep my nickels in even amounts. So I'm going to go to 16. Well, that is tripling what I did here, right? So I went up from 10 to 16. I went up 6. So that means I need to triple what I take away from here. So instead of taking 1 or 2, I know I'm going to take away 3, and that's going to leave me with 12. And just to kind of check your math, remember your goal is $2. So you should be checking, like, is 12 times 10 is $1.20. I've got 80 cents left. All right, so those nickels go in. So 16 plus 12 gives me 28 coins. So this was 10 cents times 12 dimes. And I have $1.20. And now I've got 80 cents to go. And that 80 cents I have to divide by 5. So I move that over, 2 spots. I move that over 2 spots. 5 goes into 8. Checking my math here. I've got 3 left over. I bring the 0 down. 5 goes into that 16, so that works. But again, I'm only at 28 coins. So I have yet to meet that 31 count minimum. So nobody really wants to be making these charts to guess, like, okay, what do these coins get me at $2? How do I get to 31 coins? There is a much easier way to do this. So you are going to go and continue this into activity 2. In activity 2, we're going to learn a new way of solving. So refer to these scenarios. Same scenario as activity 1. It says the graph shows the relationship between the number of nickels and the number of dimes if the total number of coins is 31. So here in this graph, you have the x-axis representing the nickels, 5 cents, and the y-axis representing the dimes, 10 cents. And if you look at this graph from end to end, you can see that the graph has a point at 31 on y, and it also has a point at 31 on x, because that's the total number of coins that we want to have between nickels and dimes. So what I want you to do, again, is pause the video, and then you're going to come back, and I want you to try to answer all the questions following all the prompts. to see if you can get to the response of how many nickels and dimes you need to equal 31 and that $2. All right, so you should have worked your way through activity 2. So it says choose a point on the graph and explain what it means in context. So you are simply choosing a point. Okay, so I'm gonna just choose a point where I meet a nice interval. I'm gonna go over to 13 here, and I'm gonna go up, not quite, oops, let's try that again. Exit that out. That is 12, so let me fix that. And go to, we're counting by 2, so this is 12, this is 14, 16, 18, 20. I'm going to choose to go to 13 because it's hitting at a point. So 12, 13's in between, but it's hitting the line right here. So this is the point 13, comma 18. It's the one I'm using, but it may not be the one that you use. So just listen closely on how I'm going to explain this, and it should work with yours as long as you chose a point on the line. So 13, comma 18 means that my X value is 13, so I have 13 nickels. And my Y value is 18, so I have 18 dimes. And if you even do the math, 13 plus 18 does equal 31, and it's on the line, so it's probably also going to equal $2. So in number 2, using the values from your table in activity 1, sketch the graph of the line that shows combinations of nickels and dimes that have a total value of $2. So what you're going to do is you're going to sketch your own graph where we want to equal the point on the line from the activity. So you can kind of see those all equal $2 from activity 1. So we have 0 and 20. So I'm going to go 0. I'm going to put a 20. I'm going back and forth that you should have done from your values up in activity 1. I have 2 and 19. Counting by 2s, 19's here in the middle. And again, this might be a little off in using Notability. Then I have 4 and 18. Still using that table from above. I have 6 and 17. And then these might be different than the ones that you used. So I did 10 and 15. And I also did 16 and 12. Oops. Now, your goal here, and if this didn't happen like it happened for me, which I did on purpose, is I need to cross that blue line. So I actually need to add another value. So to just make this easier, I can see that I have this 40 right here. So I know my X's were my nickels. So if I use 40 nickels, 40 times 0.05 is actually $2 even. That would leave me with zero dimes. So I can actually put a point right here at 40, 0. And now I can run those points through. So I'm going to connect 20, all my points that I had, because they will fall on that line, to that 40. Nice part about Notability is I do have this straight edge. And now I have a graph from my table above that asked me to do in number 2. It says label the point where the 2 lines intersect. So I'm going to use a different color here, and I'm going to label this point. And it should be right here, a little dot, and then we want to give it a number. And that number, pretty close. Label the point where the two lines intersect. What does it represent? That point looks to be 22, 9. 22 is going to represent our nickels, and 9 is going to represent our dimes. And if you add 22 plus 9, you get 31. And if you do 22 times 0.5 and you do 9 times 10, you get $2. So how did this happen? Let's talk about the equations that go with these two graphs. It says let X represent the nickels, Y represent the dimes. Write an equation that shows there are 31 total coins. So if I have X nickels plus I have Y dimes, I get 31 total. And then my other equation has to satisfy the second rule. The second rule is those coins that are 31 have to equal $2. So I know that a dime is 10 cents and a nickel is 5 cents. So if I take 5 cents times the X, which is our nickels, plus 10 cents, or 0.1, you can leave the 0 off, times Y is equal to a value of 2. I now have the two equations of the graphs you did above. The one thing I want to go over that this might seem like an added step is you could also write these two equations in y equals mx plus b format. We have yet to do that, so I am going to have you take notes on that today. So I'm going to kind of pull these equations and I'm going to rewrite them off to the side here in a different color. And I'm going to show you how to make both of them y equals. So if I take x plus, this activity did not have you do that, but I think it's important you know you can switch them around from standard form to y equals form. If I want the y on the left y equals, I can actually take away the x on both sides, which looks a little weird because it just cancels your x's, but it leaves you with y equals negative x plus 31, which is y equals negative 1x plus 31. And if you go back up to those graphs, you can see there is a y-intercept of 31 that is going downward by a slope of negative 1. Let's take a look at the other one. The other equation right here, I'm just going to go underneath it. This one's a little trickier, so I have to take this term of x over to the right side of the equal sign. So the only way to do that is to take away 0.5x on both sides of the equation. Put a line there. I'm going to write this over here. And then I have 0.1y equals negative 0.05x plus 2. Now, we're not quite there because we have a 0.1y. And when you have that, you have to divide by that 0.1 to get y all by itself. And then this makes our equation look a little weird. So we've got to kind of simplify some things. So we get y equals 0.05 divided by 0.1 on your calculator gets you negative 1/2 x. And then plus 2 divided by 0.1 gives you 20. And now you have that equation in y equals mx plus b format. And that happens to be your second line that you drew in with a y-intercept of 20 and a negative slope of 1/2. A lot of connections to make here through this lesson, but hopefully you can see that everything we've been doing with y equals mx plus b is showing you how to satisfy the two rules of equaling $2 and 31 coins total without guessing and checking in a table. You're actually graphing the equations by using the graph, which we call a system of equations. And the point on the graph, 22.9, is the actual answer to how many nickels and dimes you need to get both of those rules to work. All right, so you are going to go ahead and try the practice that is assigned to you on today's Canvas page, and then save that for the next day to go over.